In this lesson, you will learn to apply the definitions and identify the special properties of a rectangle, rhombus, and a square. So the first shape we're going to discuss is called a rectangle. And I think most people understand what a rectangle is, but here are pictures of rectangles, where by definition, a rectangle is a quadrilateral with 4 right angles. So we see here that this is the case. We have right angles in every corner. So this would be a rectangle. And even the second shape, even though technically, yes, it is a square, it is also considered a rectangle because this still has 4 right angles. The next shape is a rhombus. A rhombus, by definition, is a quadrilateral with 4 congruent sides. So on the left we see a rhombus where every side is congruent. And then the square we see again would be also a rhombus, because a rhombus has congruent sides, and a square by definition as well has 4 congruent sides. The third shape is a square. So a square by definition has 4 right angles and 4 congruent sides. So therefore a square is both a rectangle and a rhombus, as well as a parallelogram, because each of these shapes are parallelograms. Now there are some theorems to know about rectangles. The first theorem is that the diagonals of a rectangle are congruent. So in this picture, we would have AD equaling BC. Another theorem is that if one angle of a parallelogram is a right angle, then the parallelogram is a rectangle. So for example, if all I knew were that measure of angle ACD, this should be a D, if ACD were 90 degrees, if that's all we knew, then we can conclude that the quadrilateral is a rectangle. And the reason is because we know it's a parallelogram, and if it's a parallelogram, then the opposite angles are going to be congruent. So parallelogram opposite angles are going to be congruent. So this angle is also 90 degrees. And then we also know that consecutive angles will add up to be 180. So this angle, angle ACD, plus CAB would add up to be 180. Well, 90 plus another 90 is the only way to get to 180. So this would be 90 degrees, and then by default, angle D would also be 90 degrees. Now there are also a few theorems to know about rhombuses. The first theorem is that the diagonals of a rhombus are perpendicular. So the diagonals would be AD and then CB, and with the rhombus, the diagonals would be perpendicular, meaning the measure of angle AOB would have to be 90 degrees. A second theorem is that each diagonal of a rhombus bisects the 2 angles of the rhombus. Which means that if you were to look at this diagonal right here, this one is bisecting the angle on the top right, so ABD, so that now ABO is congruent to angle CBD. And also bisects angle ACD, so that ACO would also be congruent to OCD. So those would be congruent, and also using the other diagonal, that's also going to bisect the top angle, top left angle, and the bottom right angle. So now we have this angle and this angle are congruent, and then this angle and this angle are congruent. And our last theorem about rhombuses is that if 2 consecutive sides of a parallelogram are congruent, then the parallelogram must be a rhombus. So for example, if AC is equal to AB, then we can conclude that ABDC would be a rhombus. And the reason is because we know that we have a parallelogram. With the parallelogram, we know the opposite sides are going to be congruent. So that means AC must be congruent to BD, then AB must be congruent to CD. So therefore, we have 4 congruent sides, which gives us a rhombus. And that concludes our lesson for today. We will see you next time.